fundamental difference between a sequence and a series is what this video is all about. We'll take a closer look into arithmetic series. At the end of this video, you should have a better understanding, and also you should be able to answer questions involving arithmetic series. So let's get into it. What is a series? Before we go into what a series is, let's talk a little bit about a sequence. We said that a sequence is a list of numbers that are written in orders. That is a sequence. Now, the difference between a sequence and a series is that instead of we just writing an example 1, 5, 9, 14, a series would be 1 plus 5 plus 9 plus 14. So what I'm trying to explain over here is that we can say a series is the sum of the sequence. In series, just as in sequences, we have the arithmetic series and we have the geometric series. We'll be focusing on arithmetic series in this particular video. Arithmetic series follows the same pattern as an arithmetic sequence. And what I mean by that is that you still have the same A, N, D. But instead of we having Tn, we use Sn, which is our sum. There's also something that was introduced in arithmetic series, which is L, which represents the last term of your pattern. There are two formulas we use for arithmetic series. The first one is this one over here, while the second one is this one over here. So we'll be trying out 3 examples on arithmetic series. To best explain this concept, we'll focus on using both formulas that we talked about so that you can see how they can be used. Hopefully this helps you best understand what I'm trying to explain. The first question here tells us to determine the sum of 1, 5, 9, 13 to 12 terms. The formula for arithmetic series is that one over there. So all we just need to do is substitute it into there and we should be able to get our answer. Okay, so let's start with a key. Let's write down what we do have. So we have A to be 1, we have D to be 4, right? Because 5 minus 1 is 4. We have N to be 12 because we're literally told it's to 12 terms, and we are trying to find Sn. So that's all we just need to do. We put all this into our formula. So let's do that real quick. And this here will be your answer. That's it. Let's move on. Now, this is your second example. You're given a pattern which says 6 plus 1 minus 4 minus 9. And whenever you see this here, it means that there are other patterns in this series. But the last particular pattern is that one over there because that's where it ends. Okay, so now this is the sort of question in which you're given the last term. So if you're going to calculate your last term, you're going to use this formula. So we can list exactly what we do have. What do we have? We have our A to be 6. We have our N. Actually, we don't know what our N is. We are also trying to find our Sn. We have our last term, yes, to be negative 239. For us to be able to calculate our Sn, we need to find our N. And the only way we can do that is to use arithmetic sequence formula, which is this. So we would substitute our Tn with that one over there, and our D, from what we see here, D would be negative 5. So as you can see, by means of simplification, we found our N to be 50. We can put it into that formula over there and we should be able to get our answer. And as you can see, that will be your final answer, which is negative 5825. So recap real quick. The first thing we did was to find our N by using the arithmetic sequence. And after that, we can use our N into this formula for sum and we'll be able to get our final answer. And that's it. So the question here says the sum of the first 10 terms of an arithmetic sequence is 385. The sum of T4 and T8 is 84. Determine the first 3 terms. To answer this particular question, what I recommend you do is use simultaneous equation. But before we get into that, the first thing you should do is try to represent this as algebraic expression. So we're going to say now looking at this, you notice you have 2 equations by simplifying. Now all what I did over here was look at the arithmetic series formula for the S10, and the arithmetic sequence formula for the T4 and the T8. Okay, so I used the individual formula and I substituted n. N is the only known value which I have, and the Sn. With those 2, we could now do simultaneous equation. Simultaneous equation can only be used when, first of all, you have 2 unknowns like A and D, and also you have 2 equations like you can see over here. So we're going to use elimination method for simultaneous equation to answer this particular question. And that will give you your answer for the first one. When I subtract the first equation from the second equation, I would get D is equals to 7. How did I get that? 2A minus 2A gives you 0. 10D minus 9D gives you D. And finally, 84 minus 77 gives you 7. And that's where we get our common difference to be 7. To get our A, we substitute this back into any of the 2 equations. So as you can see, your A also gives you 7. So it means that my first 3 terms would be 7, 14, and 21, right? And that's exactly how they wanted you to answer this question. That's it. Okay, so you should have a better understanding of arithmetic series based on the 3 examples we just did.